Hello everyone, my name is Mark Su. One GPS application that allows people to travel without changing habits, situation, easily record bits and pieces travel process. That GPS method in combination with digital camera, the photo shoot date, time, coordinates, and altitude and azim shooting, all detailed in photos. Its characteristic is easy to operate, easy to let the photographer and relatives to share, and a clear understanding of all the travel information. Space travel routes and coordinate the process through subsequent processing digital photo files is written. So the operation, each individual user can easily travel routes and for all to share. About children and senior citizens, email alert system. Face of global society is in transition. In addition to demographic changes, personal role play and social influences are gradually changing. As the proportion of elderly population continues to rise, the advent of an aging society has been unable to avoid. Changes in society family, resulting in formation of joint and several different lifestyle. Development of GPS. Just to solve this problem, the basic principles of GPS positioning is constantly launching its own satellite parameters and time information. GPS signals receiver and receives the signal. According to the formula to calculate the position of the receiver can obtained. 3 satellites can be 2D position, 4 satellites can be 3D position, constantly updated by the receiver to receive information. You can calculate the direction and speed of movement. So to find lost family members, it is not very difficult. The combination of the track and the map is therefore one of GPS applications. GPS after identification, spatial information is recorded in digital photo.
Hello, my name is Kung Han, and I'm studying physics at NSYSU. Now I'm introducing the GPS system. GPS system stands for Global Positioning System, which was developed by United States Department of Defense. It was composed of 24 satellites. 3 of them was backup satellites. The satellite was modified to 6 different orbital planes with 4 satellites each. The orbit was arranged so that at least 6 satellites are within line of sight at almost everywhere on Earth's surface, and all of the satellites was orbit about the altitude of 20,000 kilometers. While the GPS satellites orbiting around the Earth, the GPS satellite transmits electromagnetic radiation to the ground surface. When the receiver receives the signal from the satellite, it will calculate the location of the receiver. As the radiation travels with the speed of light, when the satellite transmits a signal, it will record the time it transmitted. When the receiver receives the signal, it will record another time when it receives the signal. And to locate the receiver, we need to get the distance from the satellite to the receiver. So we use the speed of light times the difference from 2 times of record. Now I'm introducing the 3D trilateration. The trilateration is the positioning method of the GPS system. First, we have the satellite, and we calculate the distance from the satellite to the receiver. Now we can form a sphere. And the second one and the third one do the same thing. Now the 3 spheres intersect with each other. Now we can have 2 points. And if we need more precise measurement, we need the 4th satellite to calculate the distance. And now we can get the exact location of the receiver.
Hi everyone, my name is Li Junyan. My first introduction is correction of special relativity. By Einstein's special theory of relativity, for the 2 coordinate systems have relative speed. If the speed greater, the time duration effect is greater. Comparison is not precise to say that when speed reaches the speed of light, the time will be suspended. This is the first relation between GPS and the theory of relativity. After calculating the speed of satellite, the time of satellite will be slower than 7.2 microseconds time on the ground every day.
And next is projected demand for car navigation time accuracy. GPS is often used as a car navigation system to guide the driver needs to turn in those intersections. Therefore, GPS accuracy often required to be up to 30 meters, since GPS is electromagnetic wave, which is approximately equal to the transmission speed of light. The position accuracy of up to 30 meters per second signal transmission time must be equivalent to 0.1 microseconds. GPS inside and every day required to have a 8,640 microseconds accuracy.
Hello everyone, I'm Michael Chen. Today I'm going to introduce you a great achievement in history of science. This theory has a great influence to our modern life and has also been applied to our modern technology called GPS. So here's how it works. Einstein's special relativity is based on two simple tenets. The speed of light in a vacuum is always a constant no matter who is doing the measurement and no matter what direction you are moving or how fast. You always got the same speed of light. And that's assumption 1, which is shown to be true. Assumption 2, that the laws of physics as you measure them are the same for every observer, no matter who is doing the measurement. All experience has shown that these two tenets are the same and correct. This leads us to a famous twin paradox. Assume that we have a pair of twins, born at the same time and have the same age. Now, one of them we will send off 99% the speed of light, and the other one we will keep them down on Earth. Now we compare the aging rate. It turns out that the twin we sent, his clock takes 14% as fast as the other twin's clock. So the twin we sent to space is aging more slowly than the twin on Earth. It's only the paradox if you think about it into a classical terms. How could they be? But in special relativity, there's no paradox at all. That is a fundamental feature of what happens when all you do is presume that the speed of light is the same for everybody and the law of physics remain constant.